Welcome back to our session, children. In our previous session, children, we have introduced about triangles, how the triangles are said to be congruent triangles and similar triangles. Also, after that, we have discussed one of the very important theorem of your book, that is basic proportionality theorem. So, before we will proceed further, let us revise one more time what is basic proportionality theorem, and after that we will discuss about converse of basic proportionality theorem. Basic proportionality theorem says that if in a triangle there is a line segment which is parallel to one of the side of a triangle and it intersects the other two sides at two distinct points, then that two other sides are divided in a equal ratio, or we can say that two sides are in proportion. So, we have learned how to prove this theorem. Now, in today's session, we are going to start our discussion with converse of BPT, that is converse of basic proportionality theorem. Converse says, so here the given things are, in triangle ABC, D and E are the points on side AB and AC. Also, it is given to you that AD upon DB is equals to AE upon EC, and what we have to prove? We have to prove that these two lines are parallel, that is line DE is parallel to line BC. Children, here we are going to do one construction. So, here we are going to prove it by the method of assumption. Let us assume there is a point E dash on AC such that this line DE dash is parallel to BC. So, this is your construction. We have drawn this line DE dash which is parallel to line BC. Okay. Now, what we have learned in our basic proportionality theorem, that if in a triangle, if one line is parallel to the third side, then that line divides the other two sides in a ratio. So, if according to our assumption, if this DE dash is parallel to BC, then what we can write by using BPT? We can write, what we can write by using BPT, that this AD upon DB will be is equals to AE dash upon E dash C, as this DE dash is parallel to BC. But what is given to you? The given condition is that this AD upon DB is equals to AE upon EC, right. So, this is your second equation. So, children, in your first equation, we have written that AD upon DB is equals to AE dash upon E dash C. But here we are writing something else. What we are writing, that this same AD upon DB is equals to AE upon EC. So, when you compare your equation 1 and equation 2, see, two things are equal to the same thing. So, we can say that two things are equal to each other. It means from equation 1 and equation 2, what we will get? AE dash upon E dash C is equals to AE upon EC. Now, children, if these two things are equal, we can, what we are going to do in our next step, we will add 1 to both the side of this, say this is equation number 3. So, add 1 to both the side of equation number 3. On adding, if I will take LCM here, say I am writing 1 upon 1, 1 upon 1. So, E dash C will be the LCM of these two things. Here we will get E dash C, and in the numerator we will have AE dash plus this will go and multiplied with 1. So, it become E dash C here. Similarly, here also LCM is EC. So, on the numerator we will have AE plus EC. Now, see the diagram again, children. What we have written, AE dash plus E dash C. AE dash plus E dash C gives you what? This is in totality line segment AC. So, this numerator we will replace by AC. Now, see the second side, we have AE upon EC. AE plus EC is again going to give you AC. So, replace this sentence by AC. Now, check here, in both the side we have AC and AC. We can cancel this AC from both the sides. So, when you are cancelling something common, what you left with there? We left with 1. So, we received 1 upon E dash C is equals to 1 upon EC. and on doing cross multiplication, we get EC is equals to E dash C. Now children, see this step very carefully. Here we received EC is equals to E dash C. We are saying that this portion AE, EC is also equals to E dash C. This is only and only possible when point E and point E dash coincides with each other, or when these 2 points are the same point. It means point E and E dash are the same points. So initially you have assumed that DE dash is parallel to BC, and now you are saying that this E dash and E points are the same points. So what we can conclude it from here? We concluded that this DE is also parallel to BC. So hence we have proved converse of basic proportionality theorem, which says that if in a triangle, if line DE is, if two sides are divided in a equal ratio, that is AD upon DB is equals to AE upon EC, then this are divided, then the lines are parallel to each other, that is DE must be parallel to BC. That's it. Now in the next steps, children, let us do few examples of questions where we are going to use converse of basic proportionality theorem and basic proportionality theorem. So example number 1. I am giving you 2 examples, 2 figures here. See, carefully observe the figure number 1. The things which are given to you in figure number 1 is, here DE is parallel to BC, and few parts are also given to you in the diagram, that AD is 1.5 and DB is 3. AE is 1 and we need to find out this missing side, that is EC. Now children, this DE is parallel to BC, this is given to you. So what we can use here? We know when 2 lines are parallel in a triangle, then we can use basic proportionality theorem, and as per the basic proportionality theorem, when the lines are parallel, then the other 2 sides are divided in a equal ratio. So what we can write here? It means AD upon DB is equals to AE upon EC. Now substitute the values of the things which are given to you from the diagram. AD is 1.5 and DB is 3. AE is 1 centimeter and EC we need to calculate, that we don't know. So on substituting and on doing cross multiplication, what we will get? We have EC is equals to 2 centimeter. Same way, let us apply the same concept in our example number 2. Also in example number 2, the line DE is parallel to BC and the missing term here is AD. So again, since DE is parallel to BC, again we will apply basic proportionality theorem, and we can write that the sides are in proportion. So here AD upon DB is equals to AE upon EC. Now put the things in a equation. AD we need to calculate as it is, will write down. DB is equals to 7.2, AE is 1.8, EC is 5.4. Again do cross multiplication. So when you are doing cross multiplication, we found that AD is equals to 2.4 centimeter. So children, with the help of these 2 examples, you have seen that how to use basic proportionality theorem or the converse of basic proportionality theorem. Now after this, children, we are going to discuss 3 very important theorems of this particular chapter. One is AAA similarity criteria, then it is SSS similarity criteria, and the last one is SAS similarity criteria. So let's practice one more example now. So in this given figure, the things which are given to us are, this line LM is parallel to BC, first thing. Second thing, LN is parallel to CD, and what we have to prove? We have to prove that AM upon this whole AB is equals to AN upon AD. So children, you can see this whole figure is divided into 2 triangles. We are going to use the concept of BPT or converse one by one in both the triangles separately. So let's start. Here in triangle ABC, what is given to you? That this line LM is parallel to BC, and what we know according to BPT? If these two lines are parallel, then the sides are in proportion. So, write down the sides in a proportion. So, here what we will write, this AM upon MB is equals to AL upon LC, and this can also be modified as AM upon AB is equals to AL upon AC. So, this is your equation number 1 in triangle number 1. Now, select the second triangle. Your second triangle is ADC. In this triangle, the things which is given to us is AL, this line LN is parallel to CD. Okay. So, again use BPT here. Again write down the sides are in proportion. So, what we can write now? This AN upon AD will be is equals to AL upon AC. So, that is your equation number 2. Now, carefully observe your equation 1 and equation number 2. When you see here, this AM upon AB is equals to AL upon AC, and in the second case, AL upon AC is equals to AN upon ND. Again you can see there is something common. So, we know when two things are similar to one thing, they are equal to each other. So, from equation 1 and 2, what we can write now? We can write this AM upon AB, this portion will be is equals to AN upon AD, hence proved. Now children, let us arrive after this. We have reached to one of the another important thing of this particular chapter, that is criteria of similarity of triangles. Okay. So, now children, what we have learnt in our previous session, that if two triangles are congruent, what are the two conditions? Condition number 1, that the corresponding angles are equal, and condition number 2, that their sides are in proportion. But there is an important question. Is it necessary that suppose if we have to show that two triangles are similar, so is it necessary to show all the corresponding angles are equal or all the sides are in proportion? This is a question arise there. Think about it. So, the answer is no. And to solve this question, we have different criteria. So, let us start with the criteria number 1. Criteria number 1 says AAA criteria. So, that criteria is, so let us start our first criteria, that is AAA criteria or AAA criteria. This AAA criteria says that in two triangles, if the corresponding angles are equal, then the triangles are similar. I am repeating again, if in a two triangles, if corresponding angles are equal, then their sides are in proportion and then the triangles become similar. So, here in this step, we are going to prove this one of the very important theorem. Okay. So, again we have two triangles, say triangle ABC and triangle this big triangle DEF, and the things which are given to you, that the three angles of the first triangle are equals to three angles of the another triangle. Basically, angle A is equals to angle D, that we have written here, angle B is equals to angle E, and angle C is equals to angle F. So, with this condition that the three angles are equal, we need to show that the triangles are similar, and before that, to show the triangles are similar, we have to show the sides are in proportion. So, this is what we have to prove, that the triangles are similar, and as I told you, to show triangles are similar, first you have to show that the sides are in proportion. So, children, again here we are doing one construction. What we are doing in this triangle DEF, right, we are assuming that since this AB is smaller than DE. So, in this triangle on side DE we are taking point P, and on side DF we are taking point Q, such that this line AB is equals to DP and this AC is equals to DQ. Okay. So, this is your construction. Let us begin now. Here we have the proof. Now, first of all children, we will consider these two triangle ABC and the triangle DPQ. Let us take these two triangle. I am just shading these two triangle to make it more clear to you, right. Now, according to the construction, we have AB is equals to DP, that is because of your construction. Second thing, angle A is equals to angle D. Why? Because it is already given to us. And third thing, By construction again, this side AC is equals to DQ. So, we have written or we have equated three things: side, angle, side. So, if the side, angle and side of one triangle are equals to side, angle and side of another triangle, so the triangles are congruent. And what will be the criteria here? SAS. So, under criteria SAS, the triangles become congruent. Now, once the triangle become congruent, by CPCT what we can write? By CPCT we can write angle PB is equals to angle P. Also we can write angle C is equals to angle Q. Okay. Now, it is given to you that earlier it is given to us that angle B is equals to angle E, that is a given condition, and just now we have proved angle B is also equals to angle P, remember. So, if angle B is equals to angle E, also angle B is equals to angle P, what you can get from here? From here we will get angle P will be is equals to angle E. So, that is your statement now. From this we will receive the equation angle P is equals to angle E. Now, children, carefully examine this diagram. Now, if in this diagram, if angle P and angle E becomes equal, then what can you say about line PQ and EF? Recall your concept of corresponding angles. When angle P and angle E are equal, means the corresponding angles formed by two lines are equal. Then the lines are parallel. So, from here what we concluded, this line PQ is parallel to EF, right. So, we reached to this step where we have proved line PQ is parallel to EF. Now, again come to this triangle. You have just proved that line PQ is parallel to EF. If lines are parallel, so what you can write by using BPT? We can write that the sides are in proportion. So, write down that sides are in proportion, that is dP upon PE, or we can write dP upon whole DE will also equals to dQ upon DF, right. This step we reach here. But remember, according to your construction, dP is equals to what? dP is equals to AB, that is according to your construction, and dQ is equals to AC again according to your construction. So, in this equation we are going to replace dP by AB and dQ by AC. So, what we get? We get AB, since we have replaced this dP by AB and dQ by AC. So, we received or we get AB upon DE is equals to AC upon DE. So, you have shown that in these two triangles, this AB upon DE, the bigger side, is equals to AC upon DF, the another side. You are showing that the pair of two sides are in proportion. Similarly, you can do one more thing. Similarly, you can show that AB upon DE is also equals to BC upon EF. Now, since by using these two things, we can write down that all the three sides are in proportion. So, children, your given condition was that the angles are equal. You have proved that the sides are in proportion. Angles equal are there, sides are in proportion. So, what you can conclude from here? That the triangles are similar. So, hence in this way you have proved one of the very important criteria, that is known as AAA criteria, where the angles of the triangles are equal. You have shown that the sides are in proportion, then the triangles become similar. So, children, here in this way we have learnt one of the very important theorem, that is AAA similarity criteria, where it is given to you that three angles of a triangle, one triangle are equals to three angles of another triangle, and then you have shown that their sides are also in proportion and hence the triangle become similar. But again there arises a important question, children. By angle sum property we know one thing, that when two angles of a triangle are equals to two angles of another triangle. So, by angle sum property what you can conclude? That by default the third angle are also equal. So, if we are showing or if we are using that two triangles are similar using AAA criteria, is it necessary to use all the three angles? So, the answer is no. If you are able to show that two angles of the first triangle are equals to two angles of the second triangle, then also the triangles are similar under criteria AA criteria. So that AA criteria states as if two angles of one triangle are respectively equals to two angles of another triangle, then the triangles are similar, and this criteria is known as angle-angle criteria or angle-angle similarity criteria. So children, in this session we have learned two very important theorem. Theorem number 1, that is converse of basic proportionality theorem. Along with that, we have discussed similarity criteria number 1, that is AA criteria or AAA criteria. Thank you so much. So in our next session, children, we are going to discuss two more very important theorem, theorem 6.4 and theorem 6.5, which are two more similarity criteria, that is SSS criteria and SAS criteria. Thank you so much for watching this.